Hello, hi everyone. Hello, hi everyone. Hello, hi everyone. Welcome to the class. Welcome to the class. So, this is your semester. Let's start the class. Today, we are going to discuss about light reflection and refraction. Light reflection and refraction. Light is a form of energy which gives the sensation of sight. Okay, light is a form of energy which gives the sensation of sight. So light reflection and refraction. Light light reflection and refraction. So light reflection and refraction. When light is incidenting on the surface, when light ray is incidenting on the surface, it reflects back. When light ray is incidenting on the surface, it reflects back. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So I am taking this the plane mirror. This the plane mirror. Okay, so incident ray. So I am discussing about reflection of light. Reflection of light. Reflection of light. Okay, the bouncing back of the light from the reflecting surface, the bouncing back of the light from the reflecting surface, a reflecting of light from the reflecting surface is called reflection of light. Okay, so light will reflect back, so when it is incidenting on the surface, so the phenomena of bouncing back of the light from the reflecting surface is called reflection of light. Okay, so you can see here incident ray plane surface, incident ray plane surface, okay, and normal line. So this the reflected ray, and the line which is perpendicular to the plane surface is called normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. So angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And angle between, so this is the undeviated line. And the angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Okay. So that is angle of deviation. So now you can see the linear angle is 180 degrees. Linear angle is 180 degrees, that is include of, so angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay. From laws of reflection, so we'll discuss about laws of reflection. So laws of reflection, so those are laws of reflection, laws of reflection. So here you can observe, point number 1, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. And second one is angle of incidence is equal to angle of reflection. So angle of incidence is equal to angle of reflection. So this about loss of reflection. Loss of reflection is nothing but, so incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. So angle of incidence is equal to angle of reflection. So these are the two laws of reflection. Okay. And coming to the next one. So angle of deviation formula. Angle of deviation. So you can observe. So angle of incidence plus angle of deviation equal to 180 degrees. That is angle of deviation equal to 180 minus 2 angle of incidence. Okay, 180 minus 2 angle of incidence. And coming to angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. I hope it is very clear. From laws of reflection, incident ray, reflected ray, normal line lies on the same plane. From laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. These are the two laws of reflection. And coming to the reflection of light, the bouncing back of the light from the reflecting surface, is called reflection of light. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle of reflection, right? So now, we'll discuss about object and image. So before that, there is one concept, that is regular reflection and irregular reflection. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. We'll discuss those points. So regular reflection, regular reflection. So here you can observe, these are the incident light rays. Incident light rays are parallel. Incident light rays are parallel to each other. Then reflected light rays are also parallel to each other. Incident light rays are parallel. Then reflected light rays are also parallel to each other. Incident light rays are parallel, then reflected light rays are also parallel to each other. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Coming to irregular reflection, so here you can observe the surface is irregular. The surface is rough surface. So here you can observe, so I am taking like this, okay. So incident light rays are parallel. Incident light rays are parallel. Then reflected light rays are also parallel to each other. This type of reflection is called irregular reflection. Incident light rays are parallel. Incident light rays are parallel, then reflected light rays are also parallel to each other. This type of reflection is called okay. So incident light rays are parallel, then reflected light rays, that is regular. Coming to irregular, incident light rays are parallel, but reflected light rays are not parallel to each other. Okay, so here you can observe these are the incident light rays, incident light rays, incident light rays, incident light rays, and these are the reflected light rays. Okay, so incident light rays are parallel to each other, but reflected light rays are not parallel to each other. Reflected light rays. Okay, reflected light rays are not parallel to each other. Understood? So I hope it is very clear. Now, so we will discuss about object and image. So let's discuss about object and image. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Okay, so regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Okay, so let's try. So now you can see object and image. Object and image. Na, 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 na. Na, 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 na. So now object and image. So I am taking here object and image. So this is the point. Light rays are coming from the point. Okay, after reflection, those light rays are meeting at one point. After reflection, so this is the real image. And if you are extending the incident light rays, so this is the virtual object. Virtual object. The point of intersection of reflected light rays is called real image. The point of intersection of extended incident light rays is called virtual object. Okay, so next. So I am taking one more. So from this point, light rays are coming. After that, those are reflected light rays. Here also reflected light rays. So if you are extending these light rays, the image will form. So this is the real object and a virtual image. Real object and virtual image. If the object is real, image is virtual. If the object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Understood or not? So I am taking here, like this. So object is real, image is virtual. Object and image. Object is real, image is virtual. Object is virtual, image is real. Understood? So this is about object and image. Coming to the real image, the point of intersection of reflector light rays. So directly reflector light rays are meeting, that is called real image. So the point of intersection of extended incident light rays is called virtual object. And the point of intersection of extended incident light rays is called virtual image. And the point of intersection of incident light rays. From this point, incident light rays are coming. That's why that is a real object. Understood? So this is about object and image. If object is real, image is virtual. If object is virtual, image is real. Understood? Next one. Next one is so nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Understood or not? So just check once here. Nature of the image formed by the plane mirror. So I am taking like this. So here is the object. This is the object. So A dash, A and B. So this is the A. AB is the object. AB is the object. If the light rays are passing along the normal line, If the light ray is moving along the normal line, so that light ray will be reflected back into the same path. So if the light ray passes, if the light ray moves, when light ray incident along the normal line, it reflects back into the same path. It retains its original path. It moves in the same direction. So that's why I'm taking this one. So here you can also check. You can also check here. Now here you can observe incident ray, reflected ray, and this is the incident ray and the reflected ray. And here along this one I'm taking and like this also. Okay, so if you are extending those light rays, extended light rays will meet at one point. Okay, extended light rays will meet at one point. Here you can observe. So I'm extending the light rays. So those extended light rays are meeting at one point. Here you can observe. Okay, so here you can observe. So now you can see these are the extended light rays. These are the extended light rays. Those extended light rays are meeting at one point. Those extended light rays are meeting at one point. Okay. So here you can observe. So here you can see. So these are the extended. These are extended. So here you can observe. So image will form here. Image will form. So image will form. So this is the A dash and B dash. A dash and B dash. Understood? A dash and B dash. Now you can see the distance between object to mirror. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Okay. So object, find number one. Object is real. Image is virtual. Object is virtual. Image is real. Coming to the point number two. Object distance is equal to image distance. Object distance is equal to image distance. And coming to the third one. Height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the one more magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And also it shows lateral inversion. Sir, what do you mean by lateral inversion? Lateral inversion is nothing but the phenomena of converting of lateral inversion. Lateral inversion. Understood? Lateral inversion. So the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion is nothing but, so the right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. So point number one, object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. And second point is object distance is equal to image distance. Object distance is equal to image distance. And height of the object is equal to height of the image. And magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And also it also shows lateral inversion. So here magnification of the plane mirror is +1, meaning height of the image by height of the object. Here what type of image will form? Virtual, erect and same size. Virtual, erect and same size of the image will form. So coming to the lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear. Understood? So this is about object and image. and nature of the image formed by the plane mirror. And next one, reflection of light, angle, loss of reflection and angle of deviation. Those all points we discussed. Now I will explain about a spherical mirror. There are two types of spherical mirrors: concave mirror, convex mirror. Concave mirror and convex mirror. The mirror whose reflection takes place inward is called concave mirror. The mirror whose reflection takes place outward is called convex mirror. Understood? So the mirror whose reflection takes place inward, concave mirror. The mirror whose reflection takes place outward, that is called convex mirror. Okay, so concave mirror is in converging nature, convex mirror is in diverging nature. Sir, why? Because whenever light rays are incident on a concave mirror, it converge and make it false at those light rays will be reflected and meet at focus. Coming to the convex mirror, whenever light rays are incident on it, after reflection, those light rays are moving away from it. Those light rays are moving away from it. Understood? So this is about concave mirror and convex mirror. Concave mirror and convex mirror. Now, concave mirror ray rules we have to discuss. So concave mirror ray rules will discuss. After that, image formations. So concave mirror. So before that we have to discuss about terms related to spherical mirror. Terms related to spherical mirror. So concave mirror is in converging nature, convex mirror is in diverging nature. You know that, right? But what about terms related to spherical mirror? So we have to discuss about terms related to spherical mirror first. Then later we will discuss about ray rules. Okay? So terms related to spherical mirror. So I am taking, what is mirror? Concave mirror. Concave mirror. Concave mirror I am taking, right? So it is the part of the sphere. So this is a part of the sphere. This is the center of the imaginary sphere in which mirror is a part. This is the pole. Okay, center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. And the line joining of center of curvature and pole is called radius of curvature. The line joining of center of curvature and small break. Okay, so now you can see center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature, and midpoint of the mirror is called pole. Midpoint of the mirror is called pole. That is line joining of center of curvature and pole is called principal axis. The distance between center of curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis, that is called principal focus. Simply we can say focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And the width of the reflecting surface is called aperture. Okay, so these are the points related to terms related to spherical mirror. Just check once here. So the line joining of center of curvature and pole is called principal axis. So first one is center of curvature, second one is The distance between center of curvature to pole is called radius of curvature. Okay, so this is the radius of curvature. So after reflection, all light rays will meet at one point on the principal axis. That is called focus. This is the focus. Understood? And the distance between focus to pole is called focal length. The distance between focus to pole. So this the focus to pole is called focal length. Okay, F. So we can say pole. Third one, principal axis. Principal axis. And coming to the fourth one is focus. Fifth one is focal length. Sixth one is radius of curvature. Radius of curvature I didn't discuss. And the distance between center of curvature to pole is called radius of curvature. Radius of curvature. And aperture. Width of the reflecting surface is called aperture. Width of the reflecting surface is called aperture. So center of the imaginary sphere in which mirror is a part. So center of the imaginary sphere in which mirror is a part is called center of curvature, and midpoint of the mirror is called pole. The line joining of center of curvature and pole is called a principal axis. After reflection, all light rays will meet at one point of the principal axis, that is called focus. And the distance between focus to pole is called focal length. Okay, the distance between center of curvature to pole is called radius of curvature, and width of the reflecting surface is called aperture. Width of the reflecting surface is called aperture. I hope it is very clear. So these are the terms related to spherical mirror. Terms related to spherical mirror. So now we will discuss about ray rules and image formations. Ray rules and image formation. Let's start. Now, so we can see ray rules. Let's start discuss about ray rules. So this is the pole, focus, center of curvature, light ray is coming from infinity. After reflection passes through focus, point number 1. Coming to point number 2, light ray is passing through focus. So this is the pole, focus, center of curvature, light ray is passing through focus. After reflection towards infinity moves. Coming to third one, light ray is passing through center of curvature. So pole, focus, center of curvature, light ray is passing through center of curvature. It retraces its original path. Coming to the next one, so pole, focus, center of curvature, light ray is incident at the pole, it reflects back. Light ray is incident at the pole, it reflects back. So these are the ray rules. Ray rules of concave mirror. Ray rules of concave mirror. So now we will discuss about ray rules of convex mirror. Ray rules of convex mirror. Concave mirror. Concave mirror. Next, convex mirror. Convex mirror. Okay, so here you can see point number 1. So I am taking the convex mirror. When light ray is incidenting on the surface, this is the pole, focus, center of curvature. Pole, focus and center of curvature. Light ray is coming from infinity. After reflection passes through focus. So light rays passing through focus, pole, focus, center of curvature. Light rays passing through focus. After reflection moves towards infinity. Coming to third one. Pole, focus, center of curvature. Light rays passing through center of curvature. So it retraces its original path. Understood? It moves in the same direction. It passes in the same direction. If the light ray is passing along the center of curvature, it retraces its path, it moves in the same direction. And coming to fourth one, light ray is incident at the pole. So I'm taking here. So pole, focus, pole, focus, center of curvature. Light ray is incident at the pole, it reflect back. Okay. So light ray is incident at the pole, it reflect back. Understood? Like a normal reflection phenomena. The bouncing back of the light from the reflecting surface, how it is forming. So same thing here also. When light incident at the pole, it reflect back. It reflect back. Understood? So next one we will discuss about image formations. Image formations. So now image formations. So now we will discuss about concave mirror image formation. Let's start. When light ray is passing, light ray is coming from infinity. After reflection, the light rays will meet at focus. So what is the nature of the image? Real, inverted, and highly diminished. When the object is at infinity, image will form at focus. Nature of the image is real, inverted, and highly diminished. Highly diminished. Highly diminished. Highly diminished. Okay, so object is at infinity. So I'm taking the concave mirror. This is a concave mirror. Okay, so pole, focus, center of curvature. Light rays are coming from infinity. After reflection, those light rays are meeting at focus. Focus. Object at infinity. Image is forming at focus. What is the nature of the image? Real, inverted. Real, inverted, and highly diminished. Real, inverted, and highly diminished. Real, inverted, and highly diminished. So second one, object is placed beyond center of curvature. So you are taking here, object is placed, pole, focus, center of curvature, object is placed beyond C. Object is placed beyond C. Image will form between C and F. Image will form between C and F. So one light I am taking like this. After reflection it passes through focus. Another light is passing through center of curvature. The image will form between C and F. Between C and F. C and F. Object is placed beyond the C. Beyond the C. Image will form between C and F. Nature of the images. Nature of the images. Real and inverted. Size of the image is diminished. Nature of the image is real and inverted. And size of the image is diminished. Size of the image is diminished. Diminished. Understood? Coming to the third one. Next one is third one. Coming to the third one. So third one we have to draw. So third one, object is placed at C. Object is placed at C. So these are the two image formations. Next one, Next one, third one. Object is placed at C. Object is placed at C. Image will form. So I am taking the concave mirror. Concave mirror. Object is placed at center of curvature. Center of curvature. So how many letters are required to form the image of the object? Minimum two. Minimum two. Minimum two. Minimum two. After reflection, those light rays will pass through focus. So after that, those light rays incidenting at the pole. So those light rays will meet at center curvature. Object is placed at C. Image is formed at C. Nature of the image. Object at C. Image is at C. Real and inverted and same size. Same size. Next one, fourth one. Fourth one, come on. Fourth one. Object is placed between C and F. Object is placed between C and F. Where those letters will meet beyond center curvature. Beyond center curvature. Here you can observe. Beyond. How many letters are required to form the image of the object? Minimum two. One light ray, another light ray inside the pole. Those light rays are meeting here. Dun, 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 dun. Object is placed between C and F. Where image will form beyond center curvature. Object is placed between C and F. Image will form beyond C. Beyond C. Nature of the image is real and inverted. Size of the image is large. Large. Real and inverted. Size of the image is large. Large. Object is placed between C and F. Image will form and see nature of the image real and inverted. Size of the image is large. Next one, see fifth one. Object is placed at F. Object is placed at F. Image will form at infinity. Object is placed at F. Image is formed at infinity. Fifth one, concave mirror, pole, focus, central curvature. Object is placed at focus. Object is placed at focus where image will form. Image will form at infinity. One light ray I am taking like this. After reflection, those light rays are passing like this. Another light ray is coming from the object after reflection. Incidenting a pole, reflecting back and moving parallel to the moving. So one light ray is incident at the one light after reflection it passes through focus. Another light ray incident the pole, then it will be reflected back. Those light rays will become parallel. Those light rays will become parallel. Those light rays become parallel and more. Those light rays will become parallel and move like this. We assume that these light rays we assume that these light rays will meet at infinity. These light rays will meet at infinity. Object is placed at focus. Light rays will meet at infinity. What type of image will form? Real inverted and highly enlarged. Real inverted and highly enlarged. Object is placed at image is forming at infinity. Nature of the image is real, inverted and object is placed at image is formed at infinity. Nature of the image is real, inverted, and size of the image is highly enlarged. Yes or no? Highly enlarged. Real and inverted. Highly enlarged. Coming to the next one. Sixth one. Object is placed. Object is placed between F and P. Object is placed between F and P. Object is placed between F and P. Sixth one. Don't concave mirror, concave. Principal axis. Object is placed between F and P. Object is placed between F and P. This is pole. Object is placed between F and P. How many light rays are required to form the image of the object? Minimum light rays are required to form the image of the object. How many light rays? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. One light I am taking like this. After that it passes through focus. Another light rays inside the pole. After that, reflected back. If you extended this light rays, extended, dun, 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 because we are drawing with the dotted lines. Dun, 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 dun. So those extended light rays, will meet where? Behind the mirror. Behind the mirror. These are the light rays. Those light rays will meet behind the mirror. Behind the mirror. Nature of the mirror is. Nature of the mirror is. Object is placed between F and P. Image will form behind the mirror. Behind the mirror. Behind the mirror. Nature of the image is virtual and direct. Virtual and direct. Size of the image is large. Size of the image is large. Compared to the object, image size is increased. Object is placed between F and P. Object is placed between F and P. Image will form behind the mirror. Image is formed behind the mirror. Nature of the mirror is virtual, erect, and enlarged. Virtual and erect, enlarged. That is very, very, very important. 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 Very, 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 very important. Important. How many marks this question will come for the exam? 3 marks question. 3 marks question. Object is placed between F and P. Image will form behind the mirror. Nature of the mirror is virtual erect. Virtual erect. Virtual erect. Virtual erect. Virtual erect. Yellow. Yellow. Virtual erect. Virtual erect. Yellow. Very important. Very important. How many marks? How many marks? 3 marks. 3 marks. Very, very important. 3 marks question. Very, very important. 3 marks question. Object is placed. Object is placed between F and P. F and P. Image is formed behind the mirror. Behind the mirror. Nature of the image. Nature of the image. Nature of the image. Nature of the image. virtual erect, virtual erect, enlarge, enlarge, virtual erect, virtual erect, enlarge, enlarge, enlarge. How many marks? How many marks? 3 marks. 3 marks. 3 marks question. 3 marks question. 3 marks question. Very, very important. 3 marks question. Very, very important. For 3 marks question. Object is placed at F and P. F and P. Image is formed. Image is formed behind the mirror. Behind the mirror. Nature of the image is virtual erect. Nature of the image is virtual erect. Virtual erect. All enlarged image. Enlarged image. Enlarged image. Next concept is convex mirror, mirror, convex, convex mirror, convex mirror, convex mirror. Object is placed at infinity, infinity. Image is formed. Focus, focus. Nature of the image is virtual erect. Nature of the image virtual erect. Size of the image highly diminished. Highly diminished, highly diminished, highly diminished. Object is placed at infinity. Image is formed at focus. Nature of the image is this is focus, focus and curvature. Object is placed at infinity. Image is formed at focus. Light rays, how many light rays are required? Minimum 2 light rays are required. After reflection, after reflection, after reflection, after reflection, those light rays are moving away from the mirror, moving away from the mirror, moving away from the mirror, moving away from the mirror. After reflection, light rays are moving away from the mirror, away from the mirror. So now you have to extend those light rays. Extended light rays. Extended light rays are meeting at focus. Object is at infinity. Image is formed at focus. Nature of the image. Nature of the image. Virtual erect. Virtual erect. And size of the image. Size of the image. Highly diminished. Highly diminished. Highly diminished. Highly diminished, highly diminished. Object is at infinity. Image is formed at focus. Nature of the image. Virtual erect. Size of the image is highly diminished, 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 highly diminished. Virtual erect and highly diminished, 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 highly diminished. That is first one. Coming to the second one. Coming to the second one. Object is placed. So pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed between P and P and P and infinity. Object is placed between P and infinity. Now, very important, very essential. So, without the object, there is no image. That object is placed between P and infinity. If light rays are coming from that point, after reflection, those light rays are reflecting back. Reflecting back. One light I'm taking like this. After reflection, one more light ray incidenting at the pole. It reflect back. If you are extending these light rays, extended reflected light rays are meeting. Extended reflected light rays are meeting between P and F. Extended reflected light rays are meeting between P and F. Their image is forming. What is the nature of the image? Virtual and erect. Virtual and erect. Diminish. Object is placed between P and infinity. Image is formed between P and F. Nature of the image is virtual erect. Virtual erect. Virtual erect. Diminished. Virtual erect. Diminished. Virtual erect. Diminished. Virtual erect. Diminished. Object is placed between P and F. Object is placed between P and F. Image will form between P. Object is placed between P and infinity. P and infinity. Image will form between P and F. Nature of the image is virtual erect. Nature of the image is virtual erect. Size of the images. Size of the images. Size of the images diminished. Size of the image. Size of the image diminished, decreased its size. Object is placed at between P and infinity. Images formed between P and F. Nature of the image virtual erect. Highly diminished. Highly diminished. These are the convex mirror. Convex mirror. Convex mirror. Dun, 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 dun. Da-da-da-da-da-da. Now, very important, very essential. So it will be helpful for the problems. Without this one, we can't able to do the problems. We have to use these points in problems. Then only we can able to solve the problems. Each and everywhere these points must utilize. Those are sign convention. Sign conventions. Sign convention. Sign convention. Sign conventions. 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 Those are sign conventions. So here you can observe sign conventions. So I'm taking the concave mirror. Concave mirror. Concave mirror. Sign conventions. So here I'm taking the sign conventions. This is the pole, focus, center of curvature. Sign conventions. Sign conventions. Sign conventions. All measurements are taken from the pole. All measurements are taken from the pole in the direction of incident rays. All are positive. Opposite to incident rays, all are negative. All measurements will be considered from the pole, will be taken as positive. Opposite to incident rays will be taken as negative. Above the principal axis, sign conventions are positive. Below the principal axis, all measurements will be taken negative. All measurements will be considered from the pole. Yes, all measurements will be considered from the pole. In the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. All are negative. I hope it is very clear. Very, very clear. New Cartesian sign convention. New Cartesian sign convention. All measurements taken from the pole. Distance are positive along the instant rays. Distance are negative. Opposite to instant rays. Distance are positive. Above the principal axis. Distance are negative. Below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All measurements taken from the pole. Distance are positive along the instant rays. Distance are negative. Opposite to instant rays. Distance are positive. Above the principal axis. Distance are negative. Below the principal axis. New Cartesian Sign convention, you Cartesian. Sign convention. So here you can see. So if you are taking positive x-axis, negative x-axis, positive y-axis, negative y-axis. Sign conventions with respect to coordinate axis. All measurements will be taken from the pole in the direction of incident is positive, opposite is negative, above it is positive, below it is negative, as like as coordinate axis. So the measurements in this side positive, measurements opposite to that side negative, measurements above it is positive, measurements below it is negative. What are those? Object distance, image distance, focal length, and radius of curvature all are positive along the incident rays. Opposite incident rays all are negative. Above the principal axis, height of the object and height of the image positive. Below the principal axis, height of the image and height of the object negative. So I hope it is very clear. This is very important, very simple one, right? Now we will discuss about mirror formula and magnification. Sign convention, sign convention, sign convention, sign conventions, sign conventions. Dun, 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 dun. Mirror formula, mirror formula. 1 by F equal to 1 by V plus 1 by U. 1 by U, 1 by U, 1 by U, 1 by U. Yes, 1 by F equal to 1 by V plus 1 by U. So V is the image distance, U is the object distance, F is focal length. Mirror formula. Coming to magnification, so M equal to height of the image by height of the object. That is nothing but minus V by U. Magnification. So yes, I am teaching human colorful word. So magnetic effects of electric current, light chapter, and electric current. So CBSE grade 10 physics. CBSE grade 10 physics. Okay, so this is about mirror formula and magnification. So thank you so much for joining and attending and listening my class. So thank you so much. So this is Sir from Student Brand. If you like the content, if you like the channel, if you like my explanation, please do like and share and subscribe the channel. So thank you so much. Thank you so much. This is Sir. Okay. So thank you so much. So this is Sir. We'll see you in the next class. Signing off.